So hello everyone. Thanks for joining. Thanks for joining. We are going to talk about why clean code is not the norm. And well, you don't see it with these fonts, but it's important to emphasize that here clean code is written lowercase. So we are not going to talk about the otherwise good and important book of Uncle Bob, but we are going to talk about clean code as a more general concept. Please, if you have questions, to use the Q&A in Zoom. I have it open, and I will try to keep an eye on it, but I also try to keep an eye on Discord, so you can also post questions there, and I will share the slides later on. Before I will jump to the details, let me introduce myself. My name is Sandor Dargo. I'm an engineer, C++ engineer at Spotify. And in my free time, I write a lot, mostly on my blog, and mostly, but not only, about C++. I like to travel a lot, for example, to great C++ conferences. Sometimes they are online, sometimes you can actually go somewhere, but even with my two now a bit bigger but still small kids, we travel quite a lot, and I'm interested in everything that is related to let's say food and drinks, especially baking and wine making, that are in my interest. So if you want to chat about those, let me know. But that's more than enough about myself. Let's have a look at the agenda. First, we are going to discuss what is software quality. Then we'll see what is clean code, and we'll discuss if they relate to each other or not. And then we'll cover why don't we write clean code. Last but not least, we're going to see what's our job in this. So why this talk? I wanted to talk about why clean code is not the norm, because it's still not the standard way of writing code. And I've seen developers discussing this a lot and disagree a lot. We can't even agree on what quality is. So we can't agree on it. It's probably important to talk even more about it. And it's true that people just prefer blaming the others instead of taking responsibility. So that's also a motivation for me to talk about this topic. So, first question, is clean code part of software quality? Think about it. Is it part of software quality for you? What do you think? Well, to get into answering this question, let's discuss what is software quality. Is it actually a meaningful term? That's something that Derek Jones, the author of Evidence-Based Software Engineering, discussed in length in the Aura of Software Quality article. And he came to the conclusion that its meaning, it means something different to everyone. Like, a lot of people want to talk about software quality with him. And usually he asks back the question, okay, what is software quality to you? And people usually cannot answer the question. And then after some time, they come up with various different answers. They are quite different from each other. And given that people cannot agree on what software quality is, according to Derek Jones, it's just a meaningless marketing term. Because, if we can't define it, we can't really discuss about it. But there is more to this. Like, quality is undefinable, not really just software quality, but quality itself is something very difficult to define. But on the other hand, it's a bit like, according to to the anecdote from the U.S. Justice, like it is really like hardcore porn. You can't define it, but you recognize it when you see it. It's the same for quality. You see a car, you see a software, you know, okay, this is high quality, but you still cannot really define what makes it exactly uh, that. And there are philosophers, you know, writing whole books just about trying to define quality. For example, there's this great book by Robert Piercy called Zen and the Art of Motorcycle Maintenance. The interesting fact about this book is that it's really not about Zen. Actually, I was quite moved by the end. I was really not Zen by the time I finished reading it. And it's not really about motorcycle maintenance either, but at least it, it mentions motorcycle maintenance. But it it rather talks about what quality is in general. And the author came up with two main approaches to quality. The first one, I'm using color codes here that we'll use on further slides. The first one is the classical approach, and it's more about the engineering aspect, how things are built, how things work on the inside. And there is the other approach, the romantic approach of quality, and it's more about the external part, like how things are used. And that is also about the design and the aesthetics. Now, I have to mention that it's about the external design, because if we talk about software, by design, we often mean the internals of the code. But no, here we mean the external design, the aesthetics of objects or even software. So there are these two approaches, classical and romantic approaches to define quality. And now let's see how different people, how different organizations define software quality. And here I will use the color codes. So the International Standardization Organization says that software quality is capability of a software product to conform to requirements, while for others it can be synonymous with customer or value creation or even defect level. Now, this is more a romantic approach because it talks more about how things are used, right? But if you take the definition of ASQ, it says software quality describes the desirable attributes of software products. There are two main approaches exist: defect management and quality attributes. Well, this is a bit more on the classical side. It's more about the internals. Then there is the definition of Sandor Dargo. He says that a product's quality is a function of how much it changes the world for the better. Now, this is clearly about the external, the external way of using software. It's clearly the romantic approach. But there are many more definitions at Wikipedia that you can find. Now, I took one more, the definition of the Consortium for Information and Software Quality. They define 4 pillars of structural quality: security, reliability, maintainability, performance, efficiency. These are the 4 pillars that they define for structural quality of software. And this is clearly a classical approach. This is about how things are built on the inside. And we'll go with this one, with this approach, with this definition in this presentation. Now let's discuss about what is clean code. It's code that is easy to understand and easy to change. It's a bit vague, so let's go deeper in that. So what should be easy to understand? Well, it should be easy to understand the execution flow of the program, the relationships between different objects, the roles and responsibilities modules, of objects, of functions, and you should be able to go even down, even to lower levels. You have to understand the purpose of each expression. If these are easy to understand, we might be able to talk about clean code, but it should be also easy to change. And the code is easy to change when classes have concise public interfaces. Code is also easily testable. And it's not just easily testable, but it's also tested. Of course, classes and methods should be predictable and work as expected. And they should be small, have a single responsibility. Now, let's not get into details what we mean by single responsibility because it's often misunderstood. Now, if we think about these definitions of software quality and of clean code, we should ask ourselves the question again, is clean code part of software quality? And there are clearly people say that no, it's not part of software quality because as long as the code works without bugs, it's okay. And the user won't see it anyway. They won't see how the code is written. They won't see if a function is responsible for only one thing or if it's a 4,000 line long monster. They don't care. And clean code is simply fun for developers. Now, what I find really amusing about this is that well, they say that it's fun for developers, but they don't find themselves amusing writing clean code. Well, there are other people, and yeah, I have to tell that yeah, I'm probably no surprise I'm among those people. I think clean code is part of software quality because it helps reduce the number of bugs. And I put there SRM, so it increases the security of the software if you have less bugs. It's more maintainable and more reliable. So clean code helps with that. It also helps reducing the time to fix bugs because we'll go there and understand what the code is about. Probably there are already unit tests as well for most of the things, and maybe there's only some smaller things to change, or you will see from what you tested that, well, hey, I actually misunderstood what the user wanted. So we change this test to really document what they really want, and then we can change the code that is easy both to understand and to fix. So I think that this increases the reliability of the software, but okay, maybe there can be some debate there, but it definitely increases the maintainability if it takes shorter time to fix the bugs. And in the long run, clean code will decrease maintenance costs. So obviously that increases the maintainability of the software. So we see there are a couple of things like, okay, number of bugs, time to fix bugs, maintenance costs. So it's clearly part of making our job the right way. But we miss something from there, right? What about performance, you might ask? Well, performance matters, right? After all, we are C++ developers. We do care about performance. But it only matters sometimes. It's not always a cardinal aspect of our software. And even if performance matters, it's not always about runtime performance. It can be about compile time performance. It can be, well, you can even define performance in a different way, like good usage of memory, or to ship a small binary, because maybe that's how you measure your success for performance, that you keep your binary small. But even if it's about runtime performance, it usually won't be about some general algorithmic complexity of your code. So I think first you should make your code right and then optimize. Now I know that there are special fields, there are niches where this won't work because you have to keep in mind to use the best suitable data structures and algorithms from the very beginning because you can't change that at the end. Yeah, for them, probably clean code is not the best approach because they cannot pay for that in terms of performance. But in my experience in enterprise software, well, clean code is much more valuable than bringing down the algorithmic complexity. And when we had to, even scale by 10x or servers and in various teams, companies, usually it came down to how you manage network, how you manage I/O and database connections. It was never about the, let's say, the art of C++, where you can optimize a simple print by a factor of 100 or even more. There are always great lightning talks about those kind of things at conferences. I love them, but I think in most fields they don't matter so much. So if you have a special criteria, then yeah, you go for performance first and you care less about clean code. But otherwise, I think it's part of making your job right. But still, it's something expendable, something that people sacrifice first. Why is that? Is that because clean code is costly? It requires your attention, lots of effort, care from software engineers. And let's be honest, it requires more time in the beginning to write clean code than just write something that actually works. And you know, these these things like effort, care, time, they are not costs that uh, the business is usually ready to pay. It's not something that often engineering managers are willing to pay for. And often even engineers don't want to pay for that. And the problem is that quality is often lost in the midst of different constraints. So see this triangle here. There's scope, time, and the cost. But there's something else as well there. We'll see. But even if you just consider these three, if you move one point, it will impact the two other points. Well, you know, you can change the scope, you can enlarge the scope, but then you either need more time or you need more people. Somehow, time and cost will change. But we often forget about the invisible quality in the middle. And you can also play with that. And usually it's the first sacrifice before, cutting the scope or adding more time. You say, yeah, well, maybe you can just, do it a bit faster. We accrue some technical debt. We'll deal with it later. And then, well, we won't deal with it ever, usually, right? Uh, at the end, no end user cares about the quality of code. That's what we often say. And well, that's true. End users, they can't care less about the aesthetics of or code, the beauty of the code, the elegance of it. They don't care. They want one thing. Users want solutions to their problems. And they want those solutions every single moment. They are right. That's what they pay for, either by money or by their data. But I still think that clean code is not for itself, it's not l'art pour l'art. Because let's think about it. What happens if you write ugly or bad code? What will happen? Well, first, you will be fast. You will be able to ship new features very, very quickly. But then your velocity, oh, now I'm using agile terms, so your speed of delivery will slow down, and it will be more and more difficult to ship new features or to fix bugs. And actually, that's something you have to care about because the number of bugs will increase and the overall productivity slows down. And then what happens? Then it's the end. It's the end game of the software, maybe of the company. So there was this story about a company called, I think, On Time Software. They shipped a great debugger, I think in the 90s, and people loved that. But people also wanted new features, and the new features came very slowly because the code was horrible. It was horrible to maintain, and they just couldn't keep up with the competition. Their productivity was really, really low because of the low quality of their code, and soon they went out of business. So maybe in the short term, business can think, and even users can think that, well, okay, we don't care about clean code, but in the long run, it matters. Otherwise, and go out of business. And well, then you as a user have to learn something else. You have to learn the new software. So is clean code part of software quality? To me, the answer is yes, but there are other people also, uh, well, looked into this much more deeper. Think about Alan Kelly, who worked on a study for MIT, and he described this as the alignment trap. So he wanted to understand what matters more, doing the things right or doing the right things. And usually, if you ask people about it, well, um, they will say that probably doing the right thing matters more than doing things right. But the data shows something different. If you have a look at this, well, obviously the best choice, the best thing to do is being in the top right corner, doing the right things and doing the right way, and doing them the right way. So when they analyzed the numbers, they saw that, well, if I did it, they worked on the right thing and with the right ways, their IT spending went down in 3 years and their sales grew by a lot. Well, what's called the alignment trap is that you work on the good things, but you don't work the right way. And interestingly, the IT spendings went up and the sales went down in 3 years. Whereas if we go to the green corner here on the right bottom part, you can see that, well, if you do the things the right way, but you don't work on the right things, still the IT spendings went down and the sales went up. How is that possible? Well, first we can see from this that if these numbers are right, and I mean, it's a study by a prestigious organization from very knowledgeable people, we can see that making a job right is more important than making the right job. And the reason behind that is that, well, it's relatively easy to change what you do. You do thing A now, tomorrow you will work on thing B. That's easy to change. But to change how you work, to change the ways you work, that's something very, very difficult to change because it's I I see the comment. The alignment chart diagram uses the Windows logo upside down. Well, that's hilarious. I never thought about that. I am that I won't comment any more on that. Thanks for the comment. So you see, changing the way you do something is psychologically very, very difficult. So it's more important to do the things right from the beginning than delivering the right thing, because that's something you can change later on that will pay off. But then the question is, who prevents us from writing clean code? And I I saw someone asking this question quite some time ago on LinkedIn. I analyzed the answers, and I also asked this question among my friends and followers, and I found like two, three main categories. The first, people in the first category said, well, it's them, project managers. We can't write code because a clean code because of them. They can only think about the software factory where we push out new features every day or every week. And that's the only thing they want to see, new features. Uh, and many of the project managers or product owners, product managers, doesn't matter, uh, in this context, they don't even understand what technical debt is. And they don't care about clean code because, well, they don't understand its importance. But then I ask the question, should product managers, project managers understand clean code? Should they? Well, do they understand memory safety, concurrency patterns, the different forms of polymorphism? Even we developers often struggle to understand these concepts. They don't understand these. They don't understand clean code either. And it's not a problem. It's not their job. It's our job, not theirs, to understand these kind of things. Now, I'm not saying that there are no project managers who understand these kind of things, because many good developers became project managers and they didn't forget coding from one day to the other. But there are many who are not technical, and it's fine. This is not their job. It's not their job to think about implementation details in that sense. Now there is the second group of people. It's them, the junior developers. Before delving into this, do you remember that in the beginning I said that, well, people prefer blaming others instead of taking responsibility? That's what I talk about. First group, we're blaming project managers. Second one, junior developers, because they don't know how to code well. Well, that's probably true. That's why they are juniors. They just probably out of school. Oh, we don't have time to correct their code. Yeah, I remember. I've been there. I was assigned to a project when I started software development, and nobody looked after my code for maybe a month or two. And then they were horrified by what they saw in the pull request. I can understand. Well, they don't arrive with good enough knowledge. Yeah, otherwise we'd probably hire senior engineers right away from school, right? Well, the problem is that the number of juniors is exploding. Well, maybe these numbers, especially for the future, is not 100% accurate. But what you can see is that the number of developers has been and is and will rapidly growing. And we don't provide enough mentoring for junior developers. And the reason, well, let's say it's quite simple. There are simply not enough mentors. But at the end of the day, it's us, senior engineers. We are responsible uh, for delivering clean code. We are responsible for not delivering clean code as well. It's only about us. That's what I think. Because clean code is difficult. Writing clean code is difficult. And it doesn't come just by spending, I don't know, 5, 10, 15 years developing software. We have to actively learn it. We have to seek out the knowledge. Otherwise, we'll just end up writing the same low quality code that we started with. Writing clean code requires effort and discipline. Actually, learning well anything requires effort and discipline. This is not only about clean code. Now, at the same time, people, we are lazy, and more often than not, we are disorganized. That's the main problem there. So we have to do our job as senior engineers. And yes, I completely agree with you, David, saying that one of the primary objectives of senior developers should be to mentor others. And that's often the case. And I think even if it's not written somewhere, you should tell your management that, well, I will spend some time, you know, mentoring these people, formally, informally. Usually, I think that usually people don't say, well, don't do that, don't teach the others. They will be happy for that, both engineers and management. So, what's your job? Well, mentoring is part of the job, but if we start from a higher level, solving the problems of the business is our main job. The business is not, it's not a university, it's not a charity. It's there to make money for the owners. That's its main reason. And we have to help companies with that to make money. And we have to differentiate between different modes of operating, because we've been discussing about clean code. We've been discussing about, long-term concepts. But if the company you work for is in a survival mode, is trying to stay on top of the market day to day, then probably you know shipping something clean that is maintainable in the long run is not the main priority. I understand that. I understand that when I talk about clean code, there are circumstances like we discussed about performance critical niches. We could discuss lengthily about companies that just have to find their market fit, and they desperately need to ship some features and make money. Yes, but if it's not the case, then we'll see how we can break down our job into smaller parts, help the business solving the problems of the customers. So what do we do to solve business problems? Well, first, you have to write code as software engineers, preferably clean code. We have to write tests. But wait for a second, because writing tests is writing code. Test is a piece of code. So that's still code. Let's just remove that. And instead we put there, well, we have to keep learning. And we have to keep learning, not simply to remain competitive on the market, although that's not a negligible reason. But we have to keep learning so that we can solve the business problems faster and in better ways than before. And we have to communicate. And the more senior we are, the more we have to communicate. That's more the part of our job. But communication is something very vague. So let's break it down. Let's break down that part of communication. First of all, listening is everything. You have to listen. And I'm not saying this only because I'm working for Spotify, but you don't only have to listen to music. You have to listen to your colleagues. You have to listen to your stakeholders, your clients. You have to understand what their problems are, because then you might have an idea how to help them. That's one way of communication, listening. The second form I listed here is documenting. You you learn if you learn something about about the code bases, you learn something about the tools that you use to to keep your code base in shape. Well, document it. Document how it's used. Document the decisions you make, not just for the reason that like, oh, okay, now we have or documents or Confluence or Google Docs, whatever that I can measure in my performance review. No, but actually, so that when you do the same thing the next time, you will spend less time on it. Or if someone else has to do it, you just say, okay, I already documented it. This is what you have to do. So spend time on it, especially in this more and more remote context. Writing documentation and therefore moving things asynchronous is key to succeed. Education, something that was mentioned in the comments, like mentoring, is also a key form of communication. And the more senior you are, the more you have to do this. But you can educate, you know, in different forms. Uh, what I found really important. So, okay, I've been facilitating coding dojos. So, you know, places where we work on non-business critical problems, not even production problems, but we just try to solve some coding exercises in an hour or two. I've been facilitating such dojos for the last, I don't know, maybe 7 or 8 years, and I try to focus on clean code there as well, and in the production code as well. And I realized that alone, I couldn't achieve like anything, because you need more than one person who cares about this. But if there were at least two people, like uh, just one more person apart from you, if you are two, probably you can start making things better, even even without formal authority, or even without being the most senior people or most tenured people on the team. If you care about these things and you bring them up in team meetings, in different uh, chat channels, wherever, people like time, they will listen. Maybe if what you do makes sense, they will also try, and they will pay more and more attention. And by the time, they will buy what you offer. Well, which is more saner environment to code in. But what's the most important here is that don't just say, well, okay, that's how you should code because I think that, you know, uh, shouldn't have done this. And at the same time, you also deliver something horrible. No, teach by example, show example, and people will see that in the pull request, especially like I said, there should be at least two people, right? Caring about these things. If one And you don't have to plan this. It will happen naturally. If one people, comments on the others, so that, oh, okay, I like this way how you use meaningful variable names, you know, people will see it and they'll say, okay, that's a good idea. That works. I will try it next time. And let's say your community will grow by education. Sometimes we only started with 2, 3 people, these dojos as well. But as people started to see its impact on the pull request, more and more people joined. More and more people started to change the way they code for the better. So I think the best way to educate is to do it by example and to educate through like a growing community, and then the rest will take care of itself, I think. And well, eventually you might even have some systems in place, and by that what I mean is that people will care probably so much that you know they will add some special linting, or if they automate checks for this and that they didn't even think about it before, but now that they care more and more about the code quality they ship, they they will go farther and also deliver some tooling to make sure that others as well ship something you all consider in the team high quality. So we also have to explain as form of communication. And here I mean explain to the stakeholders. You have to explain to the stakeholders. You have to explain to the business, to the non-technical people, right? You have to offer sometimes alternatives. And I find this really important because sometimes they might come to you with a big problem. They came that, okay, we have this partner. They want to define which offices can do this or that by setting it in a database. Said, well, okay, to make it in a clean way, it will take us 2 months to do. Said, oh, that's impossible. We can't do it so fast. I said, well, okay, they might need the full solution right away, so we can break it down. And as a first step, let's just hard code what they want currently, and then we can ship it with the next release cycle. And then we can quickly provide some configuration. We can provide an alternative configuration through, let's say, environment variables. It will take us another week. And then in the meanwhile, we can start working on the database aspects of these things. And this led to a cleaner code because from the beginning, we thought about like, okay, we provide an interface here, and first behind the interface there will be only some hard coded stuff. Then then you read from the environment. Then we want to read from the database, but we don't want to define the API between this part of the system and the other parts. So eventually, breaking things down led to a faster shipping and also to a cleaner solution. And at the end, the database was not needed because I said, well, okay, we want to change this faster. We don't want you to spend a month on it. And they didn't want to spend the money. So they said, okay, this is already good enough. So we even saved some time there. But we also have to alert the stakeholders sometimes. It's not enough to explain, but we have to alert, and sometimes even to say no, that we are not willing to do this. Because I think our job is to, it's part of our job to be honest and say, no, I know this sounds a bit harsh, but sometimes we have to. And I have the discussion like, oh, well, I think that plan is not going to work out well. So let's tell them. Let's tell them that it's not going to work out well, and they are going to cause catastrophe. And I said, well, do we have a mandate to do the business that they shouldn't do that? And I said, yeah, definitely. And if they don't trust us enough, then maybe we should be ready to, just to go somewhere else. Because, well, if they don't listen to you, they don't listen to you to the expert. Well, maybe that's not the right place to work. Because what can happen actually if you say no? Well, maybe your objection will be heard. Maybe they will convince you that they have the right vision and you should really do that. Or they say, okay, we thought about it and, well, we reject. We cannot go that way. Say, well, we don't even care about what you say. It's not your business. I saw all of it. And I saw all of it in the same organization. In fact, it evolved a lot by time, by us building, trust because we started to deliver better and better code. So what can actually go wrong if you say no? In my idea, well, nothing really, because it's just business. It's nothing personal. And if it turns into something personal, it just shows you that, well, it's probably not the right place to work at, and you should be ready to go somewhere else. You step up, you stand up for yourself, or maybe you leave. Maybe that's what you should do. Well, at the end of the day, I think you should do what you need to do in your job. You are the expert, and don't ask how to do your job. Do you tell your doctor how to cure you? I left this one here. When we discussed this at the CPP on C in live, some people told me, yeah, I tell them. And interestingly, all of them were coming from the United States. And that was really interesting because it was really a money problem, as it turned out. Sometimes you want to tell your doctor, apparently, what they should do because of the particularities of the healthcare system. But I think, in general, at least on this side of the ocean, you don't want to tell your doctor how to cure you. That's why you pay him. That's why you pay your insurance, because you want them. You want the experts to figure out how to cure you. I don't want to solve their problems. And if I write the code one way or the other, I think it should be an implementation detail from a business perspective. They want me to ship a feature, I'll ship it my way, hopefully the right way. So I think you should do what you think is best because at the end of the day, you are the expert. You are the expert of writing code. They might be the expert of the business problems. And I don't say that, well, you should tell them that, oh, okay, I don't think that, on a business perspective, feature makes sense. Even though if you think so, probably it's right to tell them in a kind way. Maybe they will explain to you why you are not right, or maybe you are actually right. But here we talk about your expertise, which is coding. So as a conclusion, I want to say that, well, what did we discuss here? Quality is really hard to define, but in my opinion, based on all what we've seen and all what we discussed, clean code is actually part of software quality. And we also show even the database evidences that it's part of our job to make the things right, and it's better for the business in the mid and long term. So if the business you work for has a mid and long term uh, future, then write clean code. Make it part of how you do things. And remember, it's the senior developer's responsibility to pass on these values to the next generation. So there's a small call to action here from my side to you. Please go and explain to your colleagues, to your product manager, why clean code is important. If so far you haven't discussed these questions, talk about software quality, talk a bit more about it, and also set your limits, what you are willing to accept at your job, and be ready to say no if you have to do regularly things that you disagree with, that you don't like, and do lead your colleagues by example. That's the best way to educate them. And thanks a lot for joining. Thanks a lot for your attention. I think I'm on time for some questions. And I know I lost a bit the Discord. Let's maybe read it up. So, uh, yeah, the last one was from David about the alignment setup and to mentor others. We completely agree. So Alexandre asked, could tools helps writing clean code like cleanters? I think so. It won't solve the problem of writing clean code because for the time being, but actually that might change with large language model based AI. But you know the tools won't be able to tell you if, let's say, you use good variable names, but at least it can tell you if you have something too big functions, too big classes, too complex ones. If the algorithmic complexity is too big, it can at least format your code in a consistent way, and that already helps a lot. How much do you think the language affects software quality? Or do you think quality is 100% independent of the language? Um, in a sense, I do think that quality is independent of the language. I think you can write high quality code, probably any language, but what is not independent from the language probably is what kind of problems you will face more often, and also how you define quality. Uh, that probably changes between different languages. So of course there are languages where it's easier to write, let's say, code that reads like well-written prose. Like, let's say, in Python, it's fairly easy, and I'm sure there are other languages there where it's easy, but it's something I'm familiar with. It's probably easier to write readable code in Python than in C++. But at the end, how did we define software quality? So it was, what were the four pillars? There was like security, maintainability, reliability, performance, efficiency. These are mostly, I think, language agnostic concepts. Because now you might say that, whoa, you mentioned performance, and Python is not so performant as, let's say, C++, and it's completely true. But performance efficiency to me doesn't mean that you have to write the fastest code possible. It has to meet the requirements of the software, and probably the requirements of of the problem. And probably that's also how you will choose the language. If you have, if you have to write something really fast, you won't choose certain languages. I don't want to go to a language war, so I don't mention the language names here. Uh, Ask the White House, at least when referring to the security aspect of software equality. Okay, that's a good one. That came up actually in my team today, the NSA report, and I said that as long as they refer to it as C/C++, they don't have a lot of credibility. And well, uh, uh, there's this discussion on that. I see. Okay, you also shared there C/C++ is an actual language. Yeah. Uh, Paulo also said that it's a software quality is independent from the language. You can write unsafe code in Rust if you want. Yeah. We must say no reminds me to the Clean Coder book by Robert Martin by Uncle Bob. Yeah, I think this comes up more and more, not only by him but by people thinking completely differently from him, especially since there was the case with Volkswagen and the diesel engines. I think we talk about these problems more and more, and there are many different reasons to say no, both ethical and like in in a social term. Let's say that they ask you to do something unethical, but it can also mean that you know it can mean professional ethics. They don't ask you to do anything bad for the community, for the environment, whoever. But it just doesn't mean your professional standards. That's uh, that's also what I meant here. Uh, yeah, thanks, Tim, for the reminder. And it's 3 o'clock. Where I am, it's probably 2 p.m. UTC. So I propose to close this. Thanks a lot for attending and for the great discussion in the Discord. And let's move together, town. I will be there in a minute if you want to discuss, and I'd be happy to listen to you more from now on. Thanks a lot.